What's going on, everybody? We're online. All right. So, this is what we're going to be talking about today. We're going to be talking about evaluating functions for certain values and also seeing what happens when we have a function and we want to find the value of x such that, and we have the f of x value, right? So we're actually going to start off over here on this side with this problem. So it says evaluate the function g of t if g of t is equal to 7 plus 5t at each value. And the first one we're going to start with is g of 4. So whenever we're evaluating functions, what we want to do is anywhere we see the t, we're going to replace it with the 4 because that's what this is telling us to do. This is called function notation, right? So if we go into our problem here, we write g of 4 is equal to 7 plus 5, and we're going to replace that t with a 4. And then we're just going to simplify the right-hand side of this problem until we get a single number. So g of 4 is equal to 7 plus 20. Using order of operations, we're going to multiply first, and then we're going to add 7 plus 20. And that's going to give us g of 4 is equal to 27. For our next example, you're not always going to have just numbers though, so you may not be able to simplify it to a single number like we did in the last problem. In this second part of this example, we're going to have g of z minus 2. So we're going to replace the t with z minus 2 in this case. So let's go ahead and try that. So g of z minus 2 is equal to 7 plus 5 times z minus 2. Now the first thing we need to do here is distribute, right? We're going to distribute the 5 across. And so that's going to give us 7 plus 5z minus 10. Now we're going to add like terms. And so the like terms that we have here are 7 and negative 10. So we're going to combine those. And that's going to give us a final answer of 5z minus 3. And that's our final answer. For our next example, we're going to evaluate the function that h of y is equal to y plus 5 over 4 minus y. Now, this one's a little bit different because we have a variable in the denominator, and we're going to be talking more about that in the next video. But for now, we're going to evaluate these for each value. So we're going to start off with h of negative 2. So we're going to replace the y's with negative 2. So that's going to be negative 2 plus 5 over 4 minus negative 2. Remember that when you have minus and negative, we change that to a plus. So this is going to become negative 2 plus 5, which is 3. But the 4 minus negative 2 becomes 4 plus 2, and that's going to give us 6. Now, one of the important things to do whenever we're evaluating is make sure that we simplify everything down as much as we can. In this case, 3/6 can simplify down to 1/2. And that's our final answer. All right, now let's do it for h of 4. For h of 4, we're going to put 4 plus 5 over 4 minus 4. 4 plus 5 is 9, but 4 minus 4 is 0. That's not great, right? Because we cannot divide by 0. So when we have this come up, our answer is going to be undefined. So there will be some values that will not work, right? And so this is one of those, so we have to write undefined. You also need to make sure that you pay attention to this when you're working with square roots, because we cannot take the square root of a negative number yet. Our final example is a little bit different. We are given f of x, we're given the function, we're actually given the f of x value. So instead of plugging this in for x, we're going to be plugging it in for f of x. So, and then we'll have to solve the equation. So we have 7 is equal to 3x minus 5. So you see that we replace f of x with 7 in our original equation. Now we're going to solve. So we're going to add 5 to both sides. It's going to give us 12 is equal to 3x. And then we're going to divide both sides by 3 to get our final answer. And we see that x is equal to 4. Last example, we're going to use f of x is equal to negative 20. So we'll replace f of x with negative 20. Negative 20 is equal to 3x minus 5. And we're going to solve that. So we're going to add 5 on both sides. That's going to give us negative 15 is equal to 3x. Divide by 3 on both sides. That's going to give us a final answer on negative 5. So x is equal to negative 5. So this is just a brief introduction into evaluating functions for certain values and using function notation. Make sure you read your book, and also make sure that you do your web work and post in the discussion if you have any questions. See you next time.